So this is just a quick video lecture to go with what we're going to be doing in class for section 8.2, and this is proportion testing. So we're going to extend what we did last time, and we're going to go ahead and look at a left side test and a right side test. But I do want to review the proportion to two-sided test real quick before we move on to the left and the right side test. So this is exactly the same data that we used in class. In this particular example, we counted how many zeros there were, and there were 88 zeros, and it's just made up sample data. We got a p-hat or sample proportion of 0.352. Our q-hat, of course, is just 1 minus our p-hat. Our sample size is still 250. Our population proportion, hypothetically speaking, was 0.5, and q is also going to be 0.5. So the next thing, once I double check all this, I am using a 5% alpha, and so if I use a 5% alpha, I have to choose the correct critical value. So if I go to my handout here, now remember that these values only work if we're doing a proportion or a z-test. If we're using a t-test, we have to use degrees of freedom to get those values. So here you can see that for a two-sided test, our value is actually plus or minus 1.96. And so if I go here to my formula, I just want to make sure that you can see what the formula does. It's saying that if our test statistic is less than the negative of the critical value, because we have plus or minus and this is a two-sided test, we're going to reject the null hypothesis. However, if the test statistic is greater than the positive critical value, then we don't reject. And that's just a formula. You have two conditions with the if and then formula in Excel. So the next thing that I want to do is I want to make sure that I know how to calculate my test statistic. And if you remember, it's going to be our p-hat, which is 3.52, minus our p, which is 0.5, divided by the square root of p times q, divided by our sample size, which is 250. And that gave us negative 4.68. And so according to this formula, it's telling us that we're going to reject the null hypothesis. And so I'm not going to go through the steps for this particular example. We'll go ahead and do that in class. I just want you guys to have these Excel sheets, and then we'll go through the 5 steps so we know how to do it from the beginning to the end. And so then our p-value here is it's literally telling us that there's 5 zeros in front of the 2, so it's 0.000028, which is less than alpha, which confirms this conclusion that we are going to reject the null hypothesis. In other words, according to this, there is sufficient evidence at an alpha 5% and a sample size of 250 that the population proportion is in fact different than 50%. Okay, so let's go to the left side test. Now, so this is a left side test. Now, this X does not pertain to this data, so I want to make sure you understand that. This is just something I just put it in there so we can get different conclusions here so you can see the difference. We are going to keep our population, our hypothetical population proportion at 0.5. Our sample size, we're going to keep it at 250. We are going to use an alpha of 5%. Since this is a left side test, I want to make sure that we go back to our handout, and it says that our critical value for a left side or left tail test is negative 1.64, since we're looking at the left tail of the bell curve. And so that's exactly what I typed in there, negative 1.645, and that's based on the 5% alpha. So the next thing that we're going to do is calculate our test statistic, which we're going to compare to the critical value. So in this case, our step 1 for this particular example would be that the null hypothesis that the population proportion of p is equal to 0.5. Our alternative hypothesis is that p is less than 0.5. And so we took this hypothetical value here. 150 divided by 250 gave us a p-hat of 0.6, or our sample proportion was 0.6. And our test statistic will be 0.6 minus 0.5 divided by the square root of 0.5 times 0.5, which is the p-hat times, p times q, divided by our sample size, which is 250. That gave us a test statistic of 3.16. And then again, here you can see that if this formula is slightly different than the two-sided formula. And it's saying that if our test statistic is less than the negative critical value, then we're going to reject the null hypothesis. So remember, if it's to the left of the critical value, this test statistic, then that is the rejection region, and we will reject the null hypothesis. However, 3.16 is actually to the right of negative 1.64, so we do not reject the null hypothesis. The p-value for a two-sided, for a left-sided test, if we look at our handout, saying p-value, right tail test, is 1 minus norm.s.dist. So we're going to make sure that we have it. So here's going to be, oops, sorry, let me make sure I get the right one. It's a left tail test, sorry, it's not a right tail. So it's norm.s.dist, which is, this is exactly what I need. And so for this particular one, it's telling us don't reject. And so here we're going to have 0.09, which is greater than our alpha, and that supports the conclusion that we do not reject. Now, what happens if the number of zeros was less than 150? What happens if it was something like 97? So we counted 97 zeros. That gave us a p-hat of 0.388. Everything else stays the same. You can see how the p-hat and q-hat changed. But our test statistic changed, right? It went from a positive 3.16, I believe, to a negative 3.54, which is less than this critical value, right? And since it's less than the critical value, we're going to go ahead and reject the null hypothesis. And then you can see the p-value, and that p-value is it's going to have 3 zeros in front of the 1, so it's going to be 0.00019, which is in fact less than alpha, and so it supports the conclusion that we reject the null hypothesis. And so if we were writing this up, we would say something like an alpha of 5% with a sample size of 250. There is sufficient evidence to conclude that the population proportion is less than 50%. Okay, so the next one is the right side test. And so again, we're going to use a 5% alpha. I'm going to double check all my formulas first. So here's the formula for a right tail test, the p-value, and the formula for the reject and not reject. You don't have to mess around with these. The only thing that you have to do is just sort of fill all the values in, and this will, take care of itself. I want to make sure that I have the correct critical value, and it's a right tail test and an alpha of 5%, so it's 1.645. And so for this particular test statistic, I get a p-value of so I'm going to move it 2 places, so it's 0.01. And so that is in fact less than 0.05, so the conclusion is that we're going to reject the null hypothesis. And so the next thing that I want to do is I just want to, again, this value doesn't pertain to this, so I'm just going to go ahead and change this. I'm going to go ahead and say, all right, let's do 135. So here we're going to go ahead and change these values here real quick, so it's divided by that, so we get it right. So it's a 0.54, so we got a sample proportion of 0.54. Our test statistic here, we're going to go ahead and make sure that we got the correct test statistic before we do anything else. So it's going to be 1, the p-hat minus the p, divided by the square root of f2 times g2, divided by our sample size, which is 250. Just going to double check to make sure that I got everything correct. So again, p-hat minus p, so 0.54 minus 0.5 divided by the square root of p times q divided by the sample size, and so we get a test statistic of 1.26. Oops, sorry, let me move that out of the way. So I get a test statistic of 1.26 and an alpha of 5%. Here it's saying that we do not reject, and if you think about this for a second, it's saying that if the test statistic is greater than the critical value, you reject, because it would be to the right of that and it would be in the tail. Now if I change this to, let's just say 170, then we get a p-hat of 0.68, and you can see that our test statistic went to 5.69, And now we are in the rejection region because it is in fact greater than the critical value. So for this particular example, our step 1 would be the null hypothesis is the population proportion is 0.5, or the alternative is that the population proportion is greater than 0.5. And so if I was writing this up, my conclusion, I would say at an alpha of 5%, sample size of 250, there's sufficient evidence to support the claim that the population proportion is greater than 0.5. And that's the video for section 8.2. Thank you.